Alright, so today I'm going to try to talk a very interesting classical physics problems, which is called the hunter and the monkey. So let's start by look at the physical situation we have. So this is a hunter, which has a gun in his hand, and so this is the monkey, which is tied at a head edge above the ground. So this is the head edge, and so this person is a distance L away from the monkey, and this person is aiming directly to the monkey at an angle theta. And so this is the trajectory which is takes by this bullet. And the question is, will the bullet hit the monkey? So what's the necessary condition for us for this bullet to hit the monkey? So that's the question which we are interested in. And the assumption we make here is the x direction and the y direction. So for the motion of the bullet or the motion of the monkey, it's independent of each other. Okay. And the initial velocity of the bullet, so let's call it v0, and v0 can be written in its vector form by two parts, which is vxx plus vyy. And just think about this is the geometric picture which we have, vxx, vyy, and this is the angle theta. So this is the velocity v0. And we can write this in the following form. So this is the initial velocity represents the magnitude of it. So cos theta x plus v0 sine theta y. Okay. And so that's it. And now we need to figure out so what are the initial velocity for the monkey and the bullet in horizontal and vertical direction. Okay. Or the velocity, no, the initial, sorry. The velocity. It turns out, so for the bullet, it's just equal to, so this is in the horizontal direction, so v0 cos theta. And for the y direction, so which is the vertical direction, which is v0 sine theta minus jt. And for the monkey, which is, so for the horizontal direction is 0 because the monkey doesn't move in the horizontal direction. And for the vertical direction, so for the monkey, which is just equal to v0, it's just equal to minus jt. And so now we want to figure out whether the bullet will hit the monkey. So, but the bullet will travel through a distance L, right, when it hits the monkey. And so the question is, so to ask here is, when the bullet travels through a distance L, so where the monkey is, and so we can also figure out where the bullet is and whether they are at exactly the same position. If they are at the same position, so then the bullet hits the monkey. If not, it will miss the monkey, right? So the question to ask, when the bullet moves through a distance in the x direction, where the monkey is. Okay, so we need to figure out dx dt b, which is just equal to vx v0 cos theta, and so by some integration techniques, so xb, which is equal to vx dt, which is equal to v0 cos theta dt, v0 cos theta t, L, which is equal to v0 cos theta t, t, which is equal L, so divided by v0 cos theta. And we want to figure out where the bullet and the monkey is. So from the position of the monkey, so dy dt for the monkey, which is equal to minus gt. So by integration, so which is minus gt dt, so 0 to t. But it has some initial position, which is h, right? It has initial head h, and minus small 2 gt squared, and that is y. So the position of the monkey and the position for the bullet, which is equal to v0 sine theta dt minus so jt dt 0t, and so v0 sine theta t minus small 2 gt squared. So we need to see whether these two, so the equation 1 and equation 2, equal to each other or not. If they are equal to each other, it means the bullet will hit the monkey. So substitute t into this equation. Yb, which is equal to v0 sine theta L over v0 cos theta minus 1 over 2 jL squared cos theta squared, which is equal to this cancel out, so L tangent theta over 2 jL squared cos theta squared. And so for ym, which is equal to h minus 1 over 2j v0 squared, so cos theta squared. So this term, they are equal to each other. We don't really need to worry about it. But this is term we need to worry. So let's see whether these two terms equal to each other or not. We know tangent theta is also equal to HL. L times HL is just equal to H. So we can conclude, so YB is equal to YM. So this is the vertical distance which is moved by the monkey, and so this is the vertical distance which is traveled by the bullet. So it will hit the monkey. So it turns out, so the remarkable result is the initial velocity does not play a role. And so as long as you aim your bullet, your gun, directly at the monkey, it will hit the target. Okay, so as long as you point directly to, toward the monkey, so and your bullet will hit the monkey anyway. So, and the initial velocity does not play a role here. So that's really remarkable. So it's kind of hard to imagine in the first place. So okay, that's it.